In this video, we're going to talk about dilutions and go over a few problems on how to calculate dilutions using the dilution equation. So to begin, the dilution equation is as follows. M1 times V1 equals M2 times V2, where M1 is the initial molarity, V1 is the initial volume, and M2 and V2 are the final volume and concentration. The standard unit for molarity is moles per liter. So our M1 and M2 need to be in these units right here, and volume will always be in liters. Now you can do the volume, or you can have the volume in milliliters as long as both of them are in milliliters. So if V1 and V2 are both in milliliters, then it'll also work. However, you can't do V1 in milliliters and V2 in liters. So as long as you keep it consistent, then you can use milliliters or liters. Personally, I like to just convert everything to liters. So now that we know the dilution equation, let's go ahead and go over some practice problems. So the first problem is if 240 milliliters of water is added to 13 milliliters of 5 molar NaCl solution, what is the concentration of the dilute solution? So there's a lot of information in a short sentence, but we can break it down by just going through and writing down what's given and what's not given. So we know that there are 240 milliliters of water added to 13 milliliters of NaCl solution. So our initial molarity will be the molarity of our NaCl solution to start with, which is 5 molar. M2 is what we're trying to find. As you can see in the problem, what is the concentration of the dilute solution? So they want to know what is the final molarity or concentration of the solution after you add the water. We know the initial volume is 13 milliliters of NaCl. And we know our final volume, or V2, will equal 240 milliliters of water plus the 13 milliliters of NaCl. It's important to know that to remember that you need to add the two volumes together to get your final volume. So in this case, it would be 240 milliliters plus the 13 milliliters that we initially had. So if we rearrange the dilution equation, we find that M2 is equal to M1 times V1 divided by V2. We plug the numbers into the equation. We know M1 is 5 molar. V1 is 13 milliliters. I'm going to convert that to liters, which is 0.013. We'll divide that all by the final volume, which is 253 milliliters. Converted to liters, that'd be 0.253 liters. After we plug this into our calculator, we'll find that the final molarity is 0.256, is also equal to about 0.26 molar. So you're starting out with a very concentrated NaCl solution, and you have 13 milliliters of it. You're adding a total of 240 milliliters of water, which is going to dilute that solution tremendously. 240 is a lot greater than 13, so our final molarity right here, we know has to be less than 5 because we're diluting it. Our initial concentration was 5. So we know that our final concentration is going to be less than that. And in this case, it's 0.26 molar. The next problem we have is sort of a critical thinking problem. It has no numbers or anything like that. It's just to see how you can think about things in a different perspective. So the question is, how does doubling the volume of a solution by adding solvent affect the molarity? Well, we know that M1 times V1 equals M2 times V2. The question is asking, how does it affect the molarity if we double the volume? So we're looking at M2 right here. How does it affect M2 if we double the volume? So we know that M2 is equal to M1 over V1, or M1 times V1 over V2. If we're doubling the volume, that will make the V2 2V2 over M1 times V1. If the initial volume, let's just say, for example, was 1 liter, 1 milliliter, it doesn't really matter in this case. We see that the volume M2 will now equal M1 times 1 over 2. The 1 over 2 is the new ratio that compares M2 to M1. So, by doubling the volume of the solution, it affects the molarity by 1/2, or it cuts the molarity in half. This makes sense because if you think about it, you have an initial volume and the molarity is, let's just say, 2. So your initial volume, or your initial molarity, is 2 in 1 liter. 2 moles in 1 liter. Now, our concentration would be, therefore, 2 molar. Now, if we increase the volume by 2, this will now be 2 moles over 2 liters. We're not changing the amount of solvent, or we're not changing the amount of solute, we're only changing the amount of solvent. So now instead of 2 molar, this will equal 1 molar, which is equal to half of what it was originally. The next problem says a highly concentrated hydrochloric acid solution is 12 molar. What volume of 12 molar stock solution of HCl should be diluted in order to produce 6 liters of 0.5 molar HCl? So there's a lot given in this problem, but we can break it down sentence by sentence. We know we have a highly concentrated HCl solution that is 12 molar. So we know our initial molarity is equal to 12 molar HCl. We know our final volume, V2, will equal 6.0 liters. And our final molarity will equal 0.50 molar HCl. We're not given V1, and that's what we're trying to find. So if we rearrange the equation, V1 equals M2 times V2 over M1. If we plug our numbers into this equation, we'll find that V1 is equal to 0.5 times 6 over 12. 0.5 times 6 is equal to 3. So 3 over 12 is equal to 1/4, which is equal to 0.25 liters. So we need 0.25 liters of highly concentrated hydrochloric acid to make 6 liters of 0.5 milliliters, 0.5 molar HCl. It's not going to take very much if you think about this. If it's 12 molar, that's very highly concentrated. So it's going to take a very little amount of that highly concentrated acid to produce a much lower molarity final solution of HCl. The next problem is similar to the one previously when we're talking about HCl. Feel free to pause this video and try this one on your own. So this question says, a student diluted 0.8 molar HCl solution to a final volume of 550 milliliters. What will be the initial volume of the solution if the new concentration is 0.35 molar? So breaking this down, the first sentence says we have a diluted solution of 0.8 molar HCl, and our final volume is 550. So we know our V2, or final volume, will equal 550 milliliters. V1 is what we're trying to find. It says what will be the initial volume. But we don't know that one. M1 will equal the initial concentration, which is 0.8 molar. And M2 will equal the final or the new concentration of 0.35. Rearranging the equation, we know that V1 is equal to M2 times V2 over M1. So V1 will equal 0.35 times 550 milliliters, which is 0.550 liters, over M1, which is 0.8. After plugging this into your calculator, you'll find that V1 equals 0.24 liters. The next problem is similar to the previous ones, however, it is a tad bit different. So the problem says a student had 300 milliliters of 3 molar KCl solution. So right now we can go ahead and start and making our list. We know that V1 is equal to 300 milliliters. M1 is equal to 3 molar. If she concentrated the solution to 100 milliliters by heating, so final volume is 100 milliliters, what is the molarity of the final solution? 300 milliliters is also equal to 0.3 liters, and 100 milliliters is equal to 0.1 liters. Rearranging the equation, we know that M2 will equal M1 times V1 over V2. Therefore, M2 will equal 3 times 0.3 over 0.1. After putting this into your calculator, you'll find that the final concentration is 9 molar. Another way to look at this problem is you have 300 milliliters and 3 molar. You're taking the volume of 300 and you're decreasing it to 100, which is 1/3 of its initial, volume. So we know that we're decreasing the volume by 1/3 or 3 times. The 3 molar times 3 would equal 9. For this example, that works. That doesn't always work. However, you can see that the molarity is going to be larger than it was initially because you're decreasing the volume. When it says the student is heating, that means they're just evaporating off any extra solvent, such as water or anything like that, which will keep the solute in the solution, but evaporate the solvent, therefore increasing the molarity. Again, feel free to pause this video and try this next one on your own. You need to make 10 liters of 1.2 molar KNO3. What molarity would the potassium nitrate solution need to be if you were to use only 2.5 liters of it? So we're using 2.5 liters. We need to know the initial concentration, or the initial molarity, which would be X, to make a 10-liter solution that is 1.2 molar. Now we can solve for X. X will equal 10 times 1.2 over 2.5. After calculating this out, you'll find that it is 4.8 moles per liter, or molarity. Now, if you think about this, this makes sense as well. So you need to make 1.2 molar in 10 liters. If you only use 2.5 initially, which is much less than 10, the molarity needs to be more concentrated than what your final is. Now, if you were using more than 2.5 liters and you started out with, let's say, 12.5 liters, then the molarity would decrease. But since you are increasing the volume, you need to make sure that your molarity of your initial starting standard solution is much higher. In this case, that's 4.8 moles per liter. The next problem says, if you dilute 175 milliliters of 1.6 molar solution of LiCl, lithium chloride, to 1.0 liters, determine the new concentration of the solution. So based off of the last part of this problem, we're trying to find the new concentration. So we know that we are trying to find M2. We know that M1 is equal to 1.6 molar. We know that V1 is equal to 175 milliliters, is equal to 0.175 liters. We know we want our final volume to be 1 liter. Plugging these into the equation, we'll find that 1.6 times 0.175 is equal to 1x. After plugging this into your calculator, you'll find that the volume you need, or the final molarity, the new concentration of the solution, is 0.28 molar. So this next problem is a little bit more difficult, but we're going to implement the same steps we have in the past problems. The question reads, how many milliliters of 5.0 molar copper 2 sulfate solution must be added to 160 milliliters of water to achieve a 0.30 molar copper 2 sulfate solution? So we know that M1 is equal to 5.0 molar, and we don't know the initial volume. So we'll put X there. And that will equal the final volume, or the final molarity, which is 0.30 molar, times the final volume. Now for this question, we need to make sure we pay attention to this part right here, where it says must be added to. So the final volume isn't 160 milliliters, it's actually 160 milliliters plus the initial volume, or the volume that we're going to use from the initial concentration. Therefore, we're going to put X in place of that as well. When we solve this out algebraically, we'll find that 5x is equal to 48 plus 0.3x. Going even further, we'll see that 4.7x is equal to 48. Therefore, x is roughly 10.0 milliliters. This part right here, I accidentally converted to liters, so we're going to convert that back to milliliters. See, this is what I was talking about to make sure your units are correct, but good thing I caught this one. So our final volume, or the volume that we need of the initial 5 molar copper 2 sulfate is 10 milliliters. Is also equal to 0.01 liters. This problem assumes that the volumes are additive, therefore that's why the 160 plus x is necessary. If these volumes were not additive, then we would not have that plus x, it would just be 160. The next problem is also a little bit different, but again, we'll be using the same steps to go through this one as well. For this one, since there are 3 different molar concentrations, we're going to use a different formula. I wouldn't say necessarily different, but it's a little bit different compared to the normal M1, V1, M2, V2. So for this problem, we're going to use M1 times V1 plus M2 times V2 equals M3 times V3. Since we're adding two concentrated volumes of HCl to achieve a final third solution that's 0.355 molar, we have to use this equation here. So substituting the numbers in that we know 3.55 times 0.250 plus 5.65 times x is equal to 4.5 times 0.25 plus X. Again, just like the previous one, the X is necessary because we are adding these together. The volumes are added. So since we don't know the initial volume that we need of the 5.65 molar HCl, we know that we have to add the X to the 0.25 milliliters. Solving this algebraically, we'll find that it is equal to 0.8875 plus 5.65x is equal to 1.125 plus 4.50x. These numbers right here were found by taking 4.5 times 0.25 and then 4.5 times x. We're distributing the x, the 4.5 through the 0.25 plus x. Simplifying this more, we'll find that this is equal to 1.15x is equal to 0.2375, and x is going to equal 0.2065 liters. Now we're not done for this problem. X is just the number that we are substituting in for this equation. We're substituting this number into the equation. We need to add the 250 milliliters of the 0.25 liters to this X to get the final volume. So the final volume, or V3, is equal to 0.25 liters plus 0.2065 liters. And that will equal 0.4565 liters, or 456.5 milliliters. I encourage you to try this final one on your own and pause the video and come back and see if you can get the right answer. But if not, you can go ahead and keep following along with me as well. So this one is, like I said, pretty much the same as the previous one. We're going to be using the M1 V1 plus M2 V2 equals M3 V3 equation, because we have 3 different molarities and 3 different mixtures going into the final solution. So for this one, we're trying to find M3, the final molarity, or the molar concentration of the final solution. So we know that M1 is 1.80 molar times the initial volume, which is 40 milliliters, plus 0.808 molar times 21.5 milliliters is equal to M3 times 40 plus 21.5. Now, some of you may be wondering why I didn't convert the milliliters to liters. You can do that perfectly fine. However, if all the measurements or all the volumes are in milliliters, we can keep them the same, or we can keep them as milliliters. Just keep in mind that your final answer will be in milliliters and not liters. Solving this equation now, we'll see that M3 will equal 1.45 moles per liter. That's all I have for this video. Thank you for watching. If you need some more practice with dilution calculations and things like that, go ahead and check out my other video of additional problems. That's all I have for this video. Thank you for watching. If this video helped you at all, please go ahead and like and subscribe. If you have any questions, you can drop a comment and I'll be more than happy to help you and answer. So that's it for this video. Thank you for watching again, and see you in the next one. Peace.